Hello guys, this is Amit Jharola, medalist in structural dynamics and earthquake engineering and subject matter expert, the GATE Academy. Today we are going to discuss the type of sections in the limited set of collapse in Flexure. So basically we have three type of sections: balanced section, under reinforced section, and over reinforced section. So in my previous lectures we will discuss about the limited set of collapse in fracture condition, assumptions we have discussed there. Then we have seen how to calculate the moment of resistance. Then we have seen the limiting depth of neutral axis, that is the maximum depth of neutral axis, how to estimate the value, and we have seen the neutral axis constant. Now in the today's lecture we are going to discuss about how to calculate, how to determine the type of sections, right? Those and the type of sections are balanced section, under reinforced section, and over reinforced section. All these sections will be discussed one by one. You see here, let's talk about the first section, that is the balanced section. In the balanced section, what happens actually? See, as per my assumptions, I know all the compressive stresses will be taken by concrete, all the tensile stresses will be taken by steel. Suppose the strength of concrete is 20 Newton per mm square, means if I give the stress in the concrete more than 20 per Newton per mm square, the concrete will fail. In the similar way, the stress or the strength of the steel is suppose 50 Newton per mm square. Example, just it's a random values, 50 Newton per mm square. And suppose I give the value of stress more than 50 Newton per mm square in the steel will fail. So, if you create the situation in the beam in which the steel is subjected to the stress greater than its permissible limit in this case is 50 Newton per mm square, and in the concrete the permissible limit was 20 Newton per mm square. If you create any situation in which these two values, the stresses in the concrete and the stresses in the steel, reach their permissible values, the concrete will fail, this steel will also fail. Why? Because we have crossed their permissible limits. If we are crossing their permissible limit together, simultaneously, then what will happen? The section is called balanced section. So ultimately my aim to discuss here is if the stresses in the concrete are reaching their permissible value, if stresses in steel are reaching their tensile values, their permissible values together, in that case the section is called balanced section. Balancing condition, compressive force equal to tensile force, all the compressive stresses are reaching their permissible value, all the tensile stresses are reaching their permissible value together. This is called the balanced section. In that case, your depth of neutral axis will be equal to the maximum depth of neutral axis. In the previous case we have discussed. Why? Because if the section is reaching the stresses in the concrete is reaching their permissible value, that means this is giving me the strength 0.0035, that is the maximum strength. If my steel, if I talk about steel, in the steel, if the stresses are reaching their permissible value, that means they are reaching up to the 0.002 plus 0.7 Fy by S, that is the strain in the steel. That's why we say the balance section, in the balance section both materials reach their permissible value together. So here I can write in the balance section, stresses in the concrete sigma c reach their permissible value sigma c permissible. If I talk about limit state of collapse in Flexure, what is the permissible stress in the concrete? Can I say 0.446 FCK? Yes, it is the permissible limit. It is a design strength of the concrete in the structure. So this it will reach. In the same fashion, tensile stresses in the steel also will reach its permissible limit. What is the permissible limit of the tensile stress? 0.87 Fy. Already in the previous lectures we have discussed. So sigma t will be equal to sigma t permissible. And in this case, your depth of neutral axis XU will be XU max. Some people also write XU limiting. So this value will be equal to XU max, limiting depth of neutral axis. So this is called your balance section. Now let's talk about under reinforced section. What is the meaning of under reinforced? Under reinforced means you have not provided sufficient amount of reinforcement. You have provided less amount of reinforcement. If we have provided less amount of reinforcement, what will happen? Suppose my body is a reinforcement and the applied stresses are same 50 Newton per mm square, but I have provided very less reinforcement. What will happen? There is no sufficient reinforcement to resist that 50 Newton per mm square. So the steel will fail. So in this case, in the under reinforced section, first the steel will fail. Why? Because we have provided less amount of steel. So can I say, but concrete will not fail. Why? Because the stresses in the concrete is not reaching their permissible value. So in this case, in under reinforced section, stresses in steel will reach their permissible value first. Then stresses in the concrete will reach their permissible value. But when stresses in the steel already reach to their permissible value, then section will fail. It's because steel is fail. And I know steel is a ductile material. That's why this failure is called ductile failure. The complete structure will not collapse. The complete beam will not collapse. Only the cracks will be observed. Why? Because steel fails. Because it is a ductile. That beam will bend. It will show some deflection, some cracking in the concrete, in the cover of the concrete. We can observe. So we will come to know anytime if we observe this case that there is a deflection in the beam and there are some cracks, we'll come to know this is under reinforced section and beam fails in ductile failure. Anytime now if I increase the load, the stresses in the concrete may reach their permissible value. Once the stresses in the concrete reach their permissible value, the concrete will also fail and the complete structure will collapse. The complete beam will collapse. Right? I do not want my beam to be fall. I want my steel to fail. I do not want my concrete to fail. Why? Because the concrete is a brittle material. Suppose I am standing here and the beam above it is supposed to collapse. If it fails in ductile failure, no problem. There will be deflection. I will be safe. Right? But the concrete fails, suppose, what will happen? It will damage me. It will spoil. So, in that case, I want my steel to fail first, so that I can get alarm. Yeah, anytime the structure may collapse, just run out from the building. So I can run. Right? So here, what happens? Stresses in the tension reinforcement reach their permissible value. Sigma T permissible, PER is permissible. But stresses in the concrete is less than their permissible value. They are not reaching. But if we applying the force continuously, then with the time they may reach and the building may collapse. But right now, steel will collapse only if you have under reinforced section, because the stresses in the concrete are not reaching their permissible value. In this case, you can see here, this is under reinforced section, the depth of neutral axis shifted upward. So this is your depth of neutral axis. So can I say, in this case, XU is less than XU max. Your depth of neutral axis in this section will be less than the limiting depth of neutral axis, will be less than the maximum depth of neutral axis. Limiting depth of neutral axis and the maximum depth of neutral axis both are same. So this is the scenario. So I can write these sections are achieved with less reinforcement. Okay, so these are the points actually. 1, 2, 3. Here, point 1, tensile stresses reach their permissible value. Stresses in concrete are not reaching their permissible value. The depth of neutral axis less than permissible maximum depth of neutral axis. Here, this type of section is achieved with less reinforcement. Okay, less amount of reinforcement if you provide, you can achieve the under reinforced section. Now, next is, if it is under reinforced section, I know steel will fail first, and steel is a ductile material, so the failure type is ductile failure. Okay, and the next is if it is a ductile failure, I will be getting the alarm. I will come to know anytime the structure may collapse. Why? Because this still fails. Okay, so I can run and I can get the alarm. So that's why we get the alarm here. So I can write alarm. Okay, this is called under reinforced section. But let's talk about over reinforced section. What happens in the over reinforced section? In the over reinforced section, you can see, as name indicates, over reinforced. What is the meaning of over reinforced? Over reinforced mean you have provided in the section, you have provided much amount of reinforcement. If there is a much amount of reinforcement, the steel will be less, steel will be more, the concrete will be less. So what will happen when I give the force? There is sufficient steel to take the sufficient tensile stresses, but when I giving the force continuously on the member, concrete is not sufficient to take that sufficient compressive stresses, because the concrete is less, steel is more in the section. So steel will not fail here, concrete will fail first. So I can say here, in this case, the compressive stress reach their permissible value first, and the stresses in the steel reinforcement is less than their permissible value. Now, in this case, you can see the depth of neutral axis of the section exceed their permissible exceed the XU max. So here XU is greater than XU max. As I told you, it is the over reinforced section, and steel provided is more. So we can write here, with more amount of reinforcement or large amount of reinforcement, this type of section is achieved. I told you, in this case, stresses in the concrete are reaching to the permissible value. That means this concrete will fail first. If the concrete is failing first, and I know the concrete is a brittle material, so what will happen? The failure type is brittle failure. And if it is a brittle failure, suddenly the collapse. Suddenly the concrete will collapse. Suddenly the beam will collapse. Right? So there is no alarm. There is no alarm. So as a good civil engineer, what do you want? You want to prepare under reinforced section or over reinforced section. As a good civil engineer, we always want to design under reinforced section. As per IS 456-2000, we don't design over reinforced section, we always design under reinforced section. Why? Because we want to get alarm. We want alarm actually. Right? And it is a ductile failure. If it still fails, the complete structure will not fail. This beam will not fail. Okay? There will be deflection, there will be cracking. But if the concrete will fail, the structure will collapse. That is a brittle material. Okay? So it can spoil the number of lives also. So we do not want over reinforced section, we want under reinforced section or balanced section. Always we try to design balanced section only. So this is the actually the complete picture of type of section in limited set of collapse in flexure. This is not only the case for singly reinforced beam. This is the case of singly reinforced beam, doubly reinforced beam, flange type of beams, L, T, every type of beams. In every type of beams sections, you will be finding balanced section, under reinforced section and over reinforced section. So I hope you guys enjoyed. Thank you so much.